Hello, and in this lesson, we're going to continue building on VPC basics, this time focusing on subnets. Now, I know this has been a long time coming. I'm sure you may have looked at subnets in previous lessons and on the main diagram and wondering what the heck is going on with those and why have we waited this long to get to them. Well, in this lesson, we're going to talk specifically about the definitions of a subnet, the function of subnets, understanding public versus private subnets, and how to make subnets public or private. First, let's start off with a few definitions. So the simplified definition would be a subnet, shorthand for subnetwork, is a subsection of a network. A lot of subs in that sentence. Generally, a subnet includes all of the computers in a specific location. So circling back to the home network analogy we used in the VPC basics lesson, I want you to think about your internet service provider as being a network, and then your home network being considered a subnet of your internet service provider's network. So your internet service provider you can think of as a large network spanning your city or your town, and your home being a subnet in that it's its own little network within a larger network. Now, technically, that's not a great analogy, but just conceptually, that's how I want you to think about that. And it's going to make more sense in a minute when I move on to the next few slides. But in terms of an actual definition from AWS, when you create a VPC, it, meaning the VPC, spans all of the availability zones in a region. After creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. So again, I want to note that your default VPC already has subnets created in it. So we can view those here by clicking on subnets or subnets here. In the North Virginia region, the VPC will come pre-populated with 4 subnets because there are 4 availability zones within the North Virginia region. So if we look at these subnets here, we can see the availability zones that they are in. So I'll sort this by name. And currently, for each one of these subnets, we have a subnet in US East 1B, US East 1C, US East 1D, and US East 1C. So they're each within a separate availability zone. And this is so that we can provision resources in these various subnets so that they are in different availability zones, which creates fault tolerance, availability, and redundancy. So again, looking at our VPC diagram, here is a public subnet, another public subnet, a private subnet, and then another private subnet. So you may now be asking yourself, well, what's the difference between a public and a private subnet? Well, the main difference between the two is one is that public subnets have a route to the internet, where private subnets do not have a route to the internet. Here I've pulled out a public subnet and here a private subnet. So if you look here, I just took this part here and this part here and just kind of moved it up here, replacing this subnet in the diagram. And for a public subnet, it is going to have a route. It is going to be connected to a route table, and the route table is going to have an internet gateway attached, and that is going to allow information and data to flow in and out of the subnet to and from the internet. A private subnet also has to have a route table associated with it, or have the other way around, a subnet associated with a route table, but the route table cannot have an internet gateway attached. So this allows information to flow from one subnet to another within the VPC, but it will not allow traffic to go to and from this subnet through the internet gateway and out to the intranet. So how does that actually work practically, meaning in the AWS console? A second route table without an internet gateway. So let's do that first. So I opened up the route table section of the VPC. I'm going to create a new route table. And And what I want to do now is associate a subnet with this particular route table. But first, I want to make sure that I've labeled things correctly so I know what is public and what is private, or what I want to be public and what I want to be private. So let's go back to our subnets. And right now they have no names. And when you create a subnet, you have to give the subnet a name, but you can also go in at any time for your default ones and give them a name. So let's call this, and we'll match the naming construct that we've been using on the diagram. We'll call this public subnet 1. Click Save. We will call this public subnet 2. Private subnet 3. And private subnet 4. So basically what I've done here is if I go back to the previous diagram, I've just now labeled my 4 subnets to match what's going on here. But just because I labeled them public and private, again, does not make them public or private. What makes them public or private is if they have a route to the internet or do not have a route to the internet. So currently, all 4 of these subnets have a route to the internet because if I look at the route table for every single one of them, all of them are going to have a route table with an internet gateway attached. So they are all currently public subnets. So in order to make public subnets private, I need to change the route table associated with the subnets that I want private to a route table which does not have an internet gateway attached. So the one that I just created does not have an internet gateway attached, but I now need to associate the subnets that I want with this particular route table. So under the route tables, I will click on subnet associations, I will click edit, and then I'm going to select the 2 that I labeled private. So I now have 2 explicitly associated with this route table, and I know here it says 0 explicitly associated with this route table. And let me relabel this the default route table for simplicity. But if I look at the default route table, and again, it comes back to this main option here, I don't have any subnets explicitly assigned or associated to the default route table, but because it is the main, if there are subnets that aren't explicitly associated with another route table, then by default, they'll be associated with this. But I can go in here just for simplicity and to make this nice and clean and associate these 2 directly or explicitly with the default route table. And once that's done loading, what we're going to have is something that looks internally like this. So we have public subnet 1 and public subnet 2. I'll refresh this here. So for public subnet 1 and public subnet 2, those are associated with this route table here, which is this route table right here. So both are associated with this route table, which has a route to the internet. So those are public subnets. For these other 2, the private subnets, 3 and 4, they are associated with the route table that does not have an internet gateway attached, which is this route table. So in terms of actual flow of data, if we were to say have an RDS instance in the private subnet, data would flow in and out of the private subnets using the route table without an internet gateway attached and still be able to communicate with instances in the public subnets, but would not have, again, access or a route to this route table to go out to the internet. But it will need to communicate with the other route table in order to route traffic to the public subnet. So I know that gets a little bit confusing, but I hope this diagram makes sense, and just be very confident in the fact that subnets associated with a route table that does not have an internet gateway attached will be private subnets, meaning that traffic to and from the internet cannot occur, and subnets that are associated with a route table with an internet gateway will have traffic to and from the internet. And regardless, internally, they'll all still be able to communicate with each other, regardless of whether or not they are public or private, as long as they are within the same VPC. So, okay, I know that was a lot, but let's just sum everything up and talk specifically about some of the rules that we need to know. So subnets must be associated with a route table. A public subnet has a route to the internet. I know we're repeating this a lot, but this is something you really have to know and be comfortable with understanding. A private subnet does not have a route to the internet, and a subnet is located in one specific availability zone. So if we look back at our diagram here, we have availability zones. A subnet has to be only in one availability zone, as where a VPC can span multiple availability zones. And we'll get to more on that in a second. So with that, I will conclude this lesson. Thank you for watching. You may now move on.